Hi, this is Anna Lakshmi, Assistant Professor, Department of Mathematics, Sakti College of Arts and Science for Women, Ottanchitram. In this video, we will see some information about transportation problem. Let us see. Transportation model. Transportation problem is a special case of linear programming. This deals with shipping from sources to destinations. This objective is to determine amount shipped to each destination from sources at the minimum cost. This shipping costs are assumed to be constant and directly proportional to amount shipped. This is a general model of transportation problem. Here we have m sources and n destinations. M sources have m supplies and n destinations have n demands. Generally we denote the supply in AI and demand Bj. The lines join sources I to destination j. The lines carry information about the cost of transportation Cij and the amount shipped Xij. The amount of supply at source I is Ai and the amount of demand at j is Bj. This objective is to determine the unknowns Xij that will minimize transportation cost. So this is example of transportation problem. The above table shows three sources S1, S2 and S3 and four destination D1, D2, D3, D4. The numbers in the matrix are the per unit transportation cost. Next we form a model formulation. Later we take Xij. Xij means number of units from source I to j. The model will be as follows. Our aim, minimize the cost. So minimize z is equal to 19x11. That means first row first column. So plus 30x12 plus 50x13 plus 10x14 plus 70x21. Second row first column. Plus 30x22 plus 40x23 plus 60x24 plus 40x31. Third row first column. Plus 8x32 plus 70x33 plus 20x4. Next we form a constraints. So we take two types of constraints. First one, capacity constraints, that means row wise. x11 plus x12 plus x13 plus x14 is equal to 7, x21 plus x22 plus x23 plus x24 is equal to 9, x31 plus x32 plus x33 plus x34 is equal to 18. Next we form a demand constraints, that means column wise. x11 plus x21 plus x31 is equal to 5, x12 plus x22 plus x32 is equal to 8, x13 plus x23 plus x33 is equal to 7, x14 plus x24 plus x34 is equal to 14. For all xij greater than 0 for inj, that means we take the non-negative restrictions. Okay, so this is general LP model. Minimize z is equal to, that means our total cost, summation I rise from 1 to m, j rise from 1 to n, Cij into Xij. Subject to constraints, we have the two constraints, supply constraints and demand constraints. So supply constraints, summation Xij, j is equal to 1 to n is equal to I rise from 1 to m. Second one, summation I is equal to 1 to m, Xij is equal to Bj, j rise from 1 to n. This is demand constraints. All Xij greater than or equal to 0 for all inj. So this is conditions of transportation problem. So our first condition, supply always is equal to demand. This condition is also called as rim conditions. Second conditions, number of constraints are m plus n, that means m rows and n columns. Okay. Third one, number of variables are m cross n. Fourth one, supply is equal to demand is one of the constraints, and hence we have one extra redundant constraints. So thus for any feasible transportation problem we have exactly m plus n minus 1 non-negative decision variables Xij allocations satisfying all conditions. So the above condition, that means supply is equal to demand, is a balanced model. In unbalanced, supply is not equal to demand. If the number of non-negative allocations is less than m plus n minus 1, then the solution is said to degenerate. Finally, we will see solutions to transportation model. Set up in initial matrix format. Second, obtain an initial solution by any of the following methods. First one, northwest corner rule. Second one, least squares method. Third one, Wolf's approximation method. Next, test the solutions for optimality. Finally, update the solution.